But the first thing you need to look at when you're simplifying algebraic expressions is your properties of exponents, all right? Product property. This property says that if I am multiplying like bases, then I add the exponents. The examples that they give me here are x to the a times x to the b. These are the same bases, x and x. So when I multiply these, it ends up being x to the a plus b. They filled in my exponent, x cubed times x to the 4th. Multiplying like bases gives me x to the 7th. One of the ways that you often see this explained is through expansion method. So if I were to take this over here and I were to expand these out, x cubed, that is x times x times x. And I'm multiplying that times x to the 4th. That is x times x times x times x. Right? And you can see that when I expand it out, I have 7 x's. And so that's where that property comes from. When you multiply like bases, you add the exponents. I would really focus on this piece of it right here. This is what I would write down. X to the a times x to the b equals x to the a plus b. That is your product property. So then, like that product property, you have a quotient property, or what happens when you divide. When you divide, you have x to the a over x to the b. And you end up, in this situation, subtracting your exponents. All right, so when we subtract our exponents, then you end up with something like this example, x to the 7 over x squared. 7 minus 2 equals x to the 5th. All right, and if I were to do this expansion method here, what you end up having when you expand this is you have 7 x's on top. And then you have 2 x's on bottom. And we know we can reduce if we have the same thing on top and bottom. So I can reduce this 1x to 1x, 1x to 1x. And you see you end up with 5 x's left over. And that is where your property comes from. All right. Your next property is your power property. All right, your power property says if I have a power to a power, then I multiply them. The example they give me here is x cubed, and that whole group to the 4th power, which means I have x to the 12th power. And so this actually works with expansion as well. If I were to take this and I were to say, well, I have x cubed times x cubed 4 times, right? All right, then you'll notice I can actually go back to my product property. What am I supposed to do when I have like bases? Well, I should add these 3 plus 3 plus 3 plus 3. Another way to say 3 plus 3 plus 3 plus 3 is to say 3 times 4, right? And so I end up with 12 x's here. So all these properties really come from expanding these out. The next two kind of work the same, so I kind of lump these together. Whether I am multiplying or dividing, if I have something in a group, no matter how big the group is, if the entire group is taken to a power, then I have to take everything inside that group to the power, all right? So the first one is multiplying. So we have 2 times x on the inside, and that thing is taken to the 3rd power. You have to take everything in there to that power. Everything in there has to go to that power, all right? So that means when I do something like this, I have to take 2 and cube it, and I have to take x and cube it. And that is where I get 8x cubed. Anytime you have parentheses and the whole group is taken to a power, you have to take everything inside of it to the power. And you'll see the same thing is true for division. Division works exactly the same here. I have z over 3 and the whole thing is squared. That means I have to square the z and I have to square the 3, which is where I get z squared over 9. Everything in the group has to be taken to that power. The last two kind of stand on their own. You can't expand with 0, but anything to the 0 power is just 1. It's not to the first power. It is just the number 1. So x to the 0 is 1. 2 to the 0 is 1. 325 to the 0 is 1. Like anything to the 0 power is just 1. Okay? And so this actually comes from division. All right, I'm going to show you how this works with division and why this works. But if I have, let's say, I'm going to use my division property, and I have x cubed divided by x cubed. All right? Division property tells me I can subtract those. Let's expand it first, though. I have x times x times x on top, and x times x times x on bottom, right? Now I can cancel top to bottom here. X divided by x is just 1. X divided by x is just 1. X divided by x is just 1. 1 times 1 times 1 is 1, right? So if I have x cubed over x cubed, logic tells me I'm dividing something by itself, right? 5 over 5, that's 1. 25 over 25, that's 1, right? Anytime I have the same thing over each other, it is 1. Well, let's use my division property here. X cubed over x cubed. My division property says that I need to subtract those. What is 3 minus 3? 0. So another way to write x cubed over x cubed is write x to the 0, which equals 1. Just the number 1. So anything to the 0 power equals 1. It doesn't matter if it's a huge group taken to a 0 power. The whole group is going to simplify to the number 1. All right? The last one is the negative exponents. And this also works from the division property, okay? Negative exponents, they actually move places. So if you have a negative exponent in the numerator position or by itself, it's going to drop it to the denominator. If you have a negative exponent in the denominator, it's going to bump it up to the numerator. This works from the division property as well. So if I were to have x cubed over x to the 5th, all right? My quotient property says I need to subtract those, right? X to the 3 minus 5. What does that give me? 3 minus 5 is what? Negative 2. So let's use expansion here and see what happens. I'm going to have 3 x's on top. 1, 2, 3. I'm going to have 5 x's on bottom. All right? And so when I do this, move it all up. Come on. When I do this, I'm going to cancel some stuff because I can do that when I am canceling items here. So I'm going to see what I can cancel. What I can cancel 1x to 1, 1x to 1, and 1x to 1. Anytime I cancel everything in the numerator, I need to put a 1 there because it's still telling me something's in the numerator. But now I have how many x's in the denominator? 2. So this should be x squared. But it told me for my quotient property, it's x to the negative 2. That is why x to the negative 2 moves it to the denominator. So anytime you have something to the negative power, it just puts it in the denominator. So 3 to the negative 2 is the same thing as 1 over 3 to the positive 2, which is just 1 over 9. All right? It reciprocates it. So look at the next example they gave us there. 1 over b to the negative 2. Anytime you have a fraction to a negative power, you can just reciprocate it. That's the same thing as b over 1 to the positive 2. It always reciprocates it when it's to a negative power, which is why that one equals, by the way, b squared. All right. Any questions on properties of exponent? All right, A. So let's look at A specifically. When I have something like this, the first thing I do is look at my coefficients. Those are my numbers in front of these variables, okay? When I have numbers in front of the variables, I do the operation. Multiplication, I'm going to multiply the numbers. Division, I'm going to divide the numbers or reduce if I can reduce them, okay? And so the first thing I'm going to do here is I am going to deal with the coefficients. Now, if these groups were taken to some power, then I would take the whole group to the power first and then deal with the stuff inside the group. Think of it as almost an order of operations. If the whole group is to a power, you need to simplify that group first and then multiply across the groups. In this case, they're not to a power, so we're good. So the first thing I'm going to look at then are these numbers. I have 4 and -3. So I am going to multiply 4 times -3. All right? I'm going to group all of my like things. So my first like thing is number. The next one I see that I have is x. So I'm going to say, well, then I'm going to take x squared times x to the -2. All right? And then the last thing I have here are my y's. I have y to the first power. Now, for now, I'm going to write y to the first power because sometimes people forget that that actually has an exponent that we need to worry about. And then that is being multiplied by the like one of y to the -4th. All right, so I have this to represent what's going on with A. And then I'm just going to use my properties. The first one doesn't require a property. 4 times -3. What is 4 times -3? -12, all right? And then I have a property that works here. I am multiplying like bases. So look at your list of properties. What happens when I multiply? The product rule. What should I do with those exponents? So what is 2 plus -2? 0. And we're going to talk about that property in a second. All right, same thing here, like bases. So I should add them. 1 plus -4. What is 1 plus -4? It is -3. All right, so -12, that is not to a power. It is simply a number. It doesn't change. It doesn't go to the bottom. It doesn't have a negative exponent. It is just -12, all right? So -12 stays the same. We're not going to do anything to -12. That is going to remain -12, all right? That is being multiplied by this guy. But what is x to the 0? It is 1. So what happens when I multiply -12 times 1? I get -12, right? So he pretty much goes away if I'm doing multiplication. I'm multiplying by +1. It doesn't change my number, all right? The only time you really have to worry about it is if that is the only thing left in your numerator. Then you need to actually write +1. But I'm taking +1 and I'm multiplying by -12, so I can just say -12. What about this one? It is to the -3rd power. So where should it go according to my properties? In the denominator. Now, I don't have a denominator yet, but if you have something to the negative power, you're going to have to make a denominator. So -12 stays on top because it is not going to any denominator. It's not 1/12. It is actual 12, right? But I need to draw a line and I need to move that y to the denominator. And when I move it, when I reciprocate it, my exponent is now positive. So that is y to the +3rd power. And that is my answer. I cannot reduce it anymore. It is the only thing I can do, and I am done. That's my answer. 12 over y cubed. -12 over y cubed is my answer there. All right. Let's look at the next one. All right, so we are going to do B. All right, this is division. And so you don't have to write it out, but as you get better at this, you're going to maybe want to do this or not want to do this. I'm going to show you 2 ways to do it when you have division. First of all, when you have a division line, make sure your numerator is as simple as it can be and your denominator is as simple as it can be before you start working numerator to denominator. What I mean by that is, if I had r to the 4th times s times t to the 7th times r to the 3rd, that's not as simple as it could be. I could actually combine those r's, right? And so anytime you have a fraction to start off with, make sure that your numerator is as simple as possible and that your denominator is simple as possible, and then we will work top to bottom, all right? Once you have it, then you can work top to bottom. There's 2 ways to think of this, okay? The first thing we're going to do is we're just going to straight up do our quotient property. And we are going to do it based on which ones are alike. So I'm going to start with my r's. This is r to the 4th, all right? And it is being divided by r to the negative 1. What does my quotient rule say I need to do with those exponents? Subtract. So I have 4 minus a negative 1. That's what my r is going to do. 4 minus a negative 1. And then that's being multiplied by my s's. What's the exponent on this guy right here? It's 1. So don't forget that. I keep reiterating because that's a common mistake. So I have s to the first power, and my rule says I need to subtract that. So then that's 1 minus 3. And then I'm going to look at my t's. I have t on top. I have it to the 7th minus 5. All right? So far, so good. So then I'm going to simplify it. 4 minus a negative 1 is actually what? 5. 4 plus 1. And then I have 1 minus 3. So s to the negative 2. And then 7 minus 5 is t to the positive 2, right? Positive 2, right? All right. And so then I look and see, is there anything else I need to do? Do you think there's something else I need to do here? Yeah, I'm never ever going to leave something that looks different. One of those guys is different. What is it? The negative. You're never going to leave your answer with a negative exponent, okay? Not with this situation for sure. And so I need to fix that. So what does that tell me? The negative exponent is going to make that s go where? In the denominator. So I'm going to have r to the 5th and t squared. Those are positive. They're going to stay where they are. And s is going to go to the bottom, but it's going to be positive, all right? And so this is my answer, and I'm going to show you a little tip to see if you did it correctly, okay? So when I look back up here at the very top, and I look first at my r's. For just my r's, I have a 4 and a negative 1. Which is bigger, 4 or negative 1? 4. Where is the 4? Is it in the numerator or the denominator? The numerator. Where did my r end up? In the numerator. Let's look at my s. I have a 1 on top and a 3 on bottom. Which is bigger, 1 or 3? 3. Where is the s to the 3rd power? On the bottom. Where did my s end up? On the bottom. You see the pattern here? So it's a quick check of, did I do this correctly? Did I end up with what I should have logically thought I would end up with when I look at the original problem? All right. So it's a quick check of your denominators and numerators to see where it would end up. All right. So let's look at the last two. I'm actually going to bump those to the next page. All right. So anytime we have something to a power that's in a group, every single item in that group needs to be taken to the power. All right. Now, you can either simplify inside the group first, or you can take everything to the power first. All right. It doesn't matter which way you do it. It really doesn't. You're going to end up with the same answer. The first question is, can I simplify? So if I look at C, can I simplify anything inside the group? Can the 2 over 5 simplify? No, it doesn't reduce. A, there's only one A, it's on top. C, there's only one C, it's on top. And B, there's only one B, it's on bottom. So I can't really simplify. If I had multiple of the same variables on top and bottom, then maybe I could simplify first, right? Does that make sense? But as it is, nothing inside simplifies. So now that I've double checked that, I'm going to go ahead and raise everything to the power that's on the outside. So I'm going to take my negative 2. My negative 2 needs to be taken to the second power. And remember, it is a negative, so it is in parentheses. My A needs to be taken to the second power. My C to the 4th needs to be taken to the second power. My 5 needs to be taken to the second power. And my B cubed needs to be taken to the second power. And then I'm going to simplify them. So what happens when I take a negative 2, the quantity, to the second power? What does it become? Positive 4. A was to the first power squared, so it's just A squared. But what about this guy? We have a power to a power. What does my rule say to do when I have a power to a power? That's when I multiply like bases. This is a power to a power. It's called the power of a product. Yeah, multiply. So I'm going to say 4 times 2. 4 times 2. So it is C to the 8th power. All right. 5 squared. That's pretty easy. 25. Again, we have the same rule here. B cubed raised to the second power. What is it? B to the
Sixth power.
Sixth power, all right. Now, my last step before I decide whether I'm done is I want to double check and make sure I can't simplify anything. What I mean by simplify is, can I reduce my numbers? Yes or no? In this case, no, right? And then I want to make sure I only have one of each variable somewhere. So I have an A, it is to the second power, but I don't also have an A on bottom or another A on top, right? I shouldn't have an A on top and an A on bottom, or I could simplify it more. I only have one B, C, it's to the eighth power, but I don't have one anywhere else, and I only have one B to the sixth power, nowhere else. So I really can't reduce this anymore, and this is my final answer here, so I'm done with this one. Questions on that one? All right, last one before y'all do some. All right, this one's a little bit more complicated. So I'm going to look at this and I'm going to say, well, this whole first group is taken to the third power. This whole second group is taken to the negative second power. All right. And so I am going to do the groups first. Then I'm going to combine any like ones. And then I am going to simplify if I can. All right. So we're going to do each one of these. We're going to say we have 3 and it is to the third power. I have x to the 2n, and that is to the third power. And I have y squared to the third power. So I'm done with that first group for now. Then I'm going to do the second group. I have a 2. The 2 is to the negative 2 power. I have x cubed. That is also to the negative 2 power. And I have y to the negative 2m, and that is to the negative 2 power. All right, so I'm going to take each one of those first. All right, so I'm going to say 3 cubed. What is 3 cubed? 27, right? 3 times 3 times 3. Keep going. All right, this is my product, right? My power to the my power over product rule. So I multiply those. What is 2n times 3? 6n, right? So I have x to the 6n. This next guy is going to be y to the 6th power, right? This one, 2 to the negative 2. What do I do with that? It's going to be 1 over 2 squared, right? Remember, that puts it in the denominator. So what is 1 over 2 squared? 1/4, right? And then this one becomes x to the negative 6. Negative 2m times negative 2 is positive 4m. All right? I know we have variables and variables and variables, but we'll go through it. So my final step here is to combine all of my goodies that I have. I have a 27 times a 1/4. That is 27 over 4, and it does not reduce. I'm going to leave it alone. All right, 27 over 4, I'm just going to leave it. If it had been over 3, I would have made it a 9, but it's 27 over 4, it does not reduce. I'm going to look at my x's. Now this says I need to add 6n plus negative 6. Another way to say that is just 6n minus 6. Can I combine those? No, algebraically, those are not like terms. That's as simple as that x can get. I know everything in you wants to make it look prettier than that, but that's as simple as it gets, all right? For my y's, I have a 6 and a 4m. My rule says to add them. Can I make that any simpler? I cannot. They are not like terms. Believe it or not, this is your final answer here. This is as good as it gets. You cannot simplify this anymore. And so you are done with that one as well. right? Types of polynomials, really you're only going to have 3 types, and then the rest of them you're going to call polynomials. So we talked about how many terms, like from your homework. If something has terms and it has like a plus or minus in between the different multiplication or whatever. And so the way you identify them is how many terms it has. Monomial, 1. Binomial, like a bicycle, 2. Trinomial, like a tricycle, 3. And then after 3, we don't have special names. We just say polynomial with X number of terms, all right? So if it had 6 terms, you would say polynomial with 6 terms. You wouldn't just keep naming all these crazy ones like you do in geometry with sides, okay? So you really have to know monomial, binomial, and trinomial, and then the rest of them you're just going to say are polynomials. A couple things about polynomials. Degree. The degree of an individual term is the sum of all of the exponents of the variables. So all of the variables will have some type of exponent. The degree will just be those added up. So if you have x squared, your degree is 2. If you have 3xy, your degree is 2 because x and y both had a 1, right? If it is just a number, 3, or just a number, 5, with no variable, then your degree is 0 because you don't have a variable to show, okay? So then what is the degree of a polynomial? Let's say you have multiple terms. What you're going to do when you have multiple terms is see which one has the highest degree, which of your individual terms, and that represents the degree of the entire polynomial. So let's look at examples 2 and 3. Determine the degree of each one, all right, and then the degree of the polynomial. So remember, we're only looking at the exponents of the variables and we're adding them up. So this one, x has a degree of what? Yeah, a 2, 2xy, because x is to the first power. Y is to the first power. When I add them up, my degree of the whole thing is 2. What about b? What's my degree here? 3. 2 and 1. What about this guy? 6. 3, 1. Don't forget him. And 2. And then what about the last one? What's the degree?
0.
It's 0. And technically, we have this guy here. That's why, right? If you don't see a variable, there's something to the 0 power is what you can assume. But the degree of any constant is 0. Always. All right, let's look at 3. So for 3, I'm going to look at each of the terms, and I'm going to figure out those. So I'm going to say, well, 4x cubed y, that has a degree of 4. 7x squared y cubed, that has a degree of 5. And 15y to the 4th has a degree of 4. And I'm going to look at those, and I'm going to say, well, the degree of the whole thing is going to be the highest. I don't add these up. I look at my individual terms, and whichever is highest, that is the degree of the entire polynomial. So this guy is 5. All right. The degree of this one is 5. Questions on finding degrees? All right. And subtracting. Just a reminder, like terms. Like terms are terms that have the same variable with the same exponent. So x squared is a like term to x squared. It is not a like term to x cubed, right? So every variable in the term has to be the same, and every exponent of those variables have to be the same. If they are, then you can add their coefficients. So I can add what's in front of them if they are alike. And that's all you do to simplify the addition and subtraction of polynomials. So let's look at this first one. We are adding. Very important. Biggest problem here is just your positives and negatives. All right, so I always check and make sure I am adding. And so that's what I'm doing here with number 4a. All right, and then I'm just going to verify my like terms. I have 3x squared plus 5x squared. Those are alike. So I can add my 3 and my 5. And I am going to get 8x squared. Then I'm going to look at the next group here. I have a positive 2x plus a negative 3x. What's positive 2 plus negative 3? Negative 1x. And when it's a 1, you don't have to write it, the coefficient. And then the last one is my constant here, negative 8. And my constant here, positive 9. Negative 8 plus 9 is positive 1. And this is my answer. 8x squared minus x plus 1. I can't simplify that anymore. I don't have any like terms. All right? Subtraction. A little key here. If you struggle with positives and negatives, you may want to change this to adding the opposite. All right, so I'm going to show you both ways. If you want to leave it as subtraction, that's fine, but keep in mind you're always subtracting, okay? If you don't, you can change it to adding, and you can change all of these to the opposite. Negative 5a cubed b, negative 3ab squared, positive 4ab cubed. All right, so you don't have to do that method, but make sure you remember you are subtracting, okay? Now, something different about this one as well is we have a 2a in front. Before you start adding and subtracting, it's like everything else. You have to distribute first, okay? So we are going to distribute this guy first. 2a times 2ab squared. 2 times 2 gives me a 4. A and a squared gives me an a cubed. And then I just have a b. 2a times ab. I have just a 2. A and a, that's a squared. The b is by itself. It's going to stay. And then 2a times negative 4b cubed. 2 times negative 4 is negative 8. The a doesn't have anything. The b doesn't have anything, so it stays the same. Okay? And then you can start combining by addition and subtraction. So I have a cubed b. Do I have that in the second set? Yes. Now you can think of it this way. 4a cubed b minus 5a cubed b. Or if you did it to adding the opposite, 4 plus a negative 5. Either way, you're going to get negative 1, right? Negative 1a cubed b, right? And then I'm going to check the next one. Like terms, a squared b. Do I have an a squared b in the next group? I don't. I have an ab squared. So that's not like. So I actually cannot combine this one with anything. So this is going to stay 2a squared b, right? What about ab cubed? Do I have that? Yes, I do. But that means this guy is also not going to have a like term. Do you see why I'm underlining them? Why do you think I'm underlining them? Because if not, which one would I forget? Yeah, the guy in the second group that didn't have a like term. Do you notice I'm underlining him? That is just a method I'm using to check off that I did it all, okay? So I would actually list this guy next. Negative 3ab squared. It doesn't really matter which way you do it, but usually they go up. So they go down by the a's and up by the b's, typically is how you would list it. So now I'm going to do these. Negative a and positive 4. Negative a and positive 4. Or you could have said minus a negative, but either way you add it. So you end up with a negative 4ab cubed. And this would be my answer here. All right, does everybody see that? So you do want to implement some type of method when you're adding these across to make sure you have accounted for every single term, or you're going to forget one. I would forget one because you're just going to assume you did it. All right, because very often you'll go through the first set and you'll ignore anything in the second set that doesn't have a like term. All right, so I want you to try a couple of these.